We are back at it. Yes, we are back at it. So yeah, today we're just gonna determine the general solution of x in the following equation. When you look at the equation, it looks quite tricky, doesn't it? But believe you me, guys, it has nothing complicated with it. It is just application of basics from different concepts or chapters. Then when you coalesce them, you realize that it is just one simple question that requires you to have background knowledge from other concepts. But otherwise, you know what we do, you know how we do it in the on request questions. So yeah, this question is specifically requested by Baleshonolo Phehla from Mametlake Secondary School. So yeah, she sent this question, say, Mr. Sir, let's do this. Let's help others. Help others as well. Yeah. So yeah, guys, sending these questions through mean not only do you need help, but you also not selfish to, only get the help for yourself, but also for others. So keep them coming, guys. Keep them coming. Otherwise, let's solve this question. When you look at this question, it's an exponential question, but at the same time, they want the general solution of x. So basically, this is trigonometry and algebra simultaneously in one question. So when you look at it, you first going to have to ask yourself this question: how am I going to find a general solution of a trigonometric expression that is inside an algebraic expression? By first simplifying this into a trigonometric expression first, applying algebra. So this is an exponential equation, which means you have to solve this using exponential rules. But at the same time, before we even go to exponential rules, again, this is a quadratic equation because we have three terms, right? In algebra, let's look at it like this, okay? In algebra, you have something like this, guys. In algebra, if you were to be given, let's say 3 2 to the exponent x, 2x, 3 to the exponent 2x minus 3x plus 1, which is equals to 54. Let's say our tan x, right? Let me use a red pen. Let's say our tan x was just x. You see, this is an exponential equation. But at the same time, what type of exponential equation is this? We have three types. Three types. Yeah, remember I told you those I taught before. Remember I told you we have three types of exponential equations, especially for metric. The first type would be this one, where you have something like, let's say you have 2 to the exponent x plus 1 times 4 all over 8 equals to 2 to the exponent x, blah, blah, where you just simplify and solve for x, right? This is the first type. And the second type is where you have something like what? When you have something like 2 to the exponent x plus 1, maybe plus, let's say 2 to the exponent x equals to, let's say 5, right? The moment you see two terms on your exponent, the moment you see two terms on your exponent, one being the variable and the other being a constant, and you have another term consisting of a variable, you know that you have to separate the two so that the 2 to the exponent x blah blah blah. I'll treat such questions. You can actually send one so that I can treat them as one of the on request questions. But this type specifically is this type where you have 2 to the exponent 2x. So with this one, you realize that it's only multiplication and something on the other side. With this one, the x does not have a coefficient of 2, but we have two terms, right? And the other x doesn't have a coefficient. It can also be two terms or just one term, and something on the other side doesn't have an exponent of x. So you know that's where now you separate. With this one, your x will have a coefficient of 2, and another term will have your x being added onto another expression sometimes. And if it's not added to another expression, then it's even simpler. Then you have maybe just a constant. So with this type, you require to let 2 to the exponent x, this one that has this, to be k, right? Then this 2 will be on this side. Remember, when you have a, b being equated to something, or let's just say a multiplied by b, this is the same as b times a, right? So if I have a, b, this is the same as b, a, and I can put my brackets like this or bracket like this, or I can say b, a, right? And according to the laws of exponents, again, guys, remember, if I have a to the exponent c multiplied by 2, this is the same as a to the exponent c all squared, right? if you remember the laws of exponents. So this is what I'm going to do with this. Okay? Are you with me? So look at this. This is what I'm going to do. It means I will take my 2 and put it outside the brackets, and my 3 to the exponent x will be inside the brackets. And here I will just separate the 2. So basically moving from here to here, treating this tan x as my x, I will just say what? 3 to the exponent tan x. This tan x is the same as x, right? And I will put it inside brackets, and the 2 I will take it out. Then I will say minus 3 to the exponent what? Remember, it's tan x plus 1. This is the same as tan x again, right? Multiplied by, right, 3 to the exponent 1. So I just separate them, right? Then I will transpose this one. I'm going to make it 54 being equated to 0. Okay? So now what you have is 3 to the exponent tan x. 3 to the exponent tan x. I can put this inside my brackets, parenthesis, meaning multiplication. So now it means I can take this and let it be equal to k. So I'll just say let k to be 3 to the exponent tan x, so that I will have a quadratic expression. So look at it. Look at the magic. This is where the magic comes. You just say k to the exponent 2. Where you see 3 to the exponent tan x, you substitute by k, right? So here I will put my k, I will put my k, then I will solve for k. Easy, right? So it's k squared minus 3 to the exponent 1 is the same as 3. I have k here, so this is going to be 3k, right? Or k multiplied by 3 is the same as 3 times k, which is 3k. So I'm going to have 3k minus 54 being equated to 0. Guys, this is easy, right? So from here, you know how to use quadratic equations. You can even solve this by using general quadratic formula, or you can just factorize, right? So I'm going to post a video one day about factorization, you know, different systems of factorizing, or how to duck factorization in an exam. And guys, don't tell your teacher. Don't tell your teacher. I'm teaching you this trick so that you can pass, but don't tell your teacher. So otherwise, so you're going to do what? You're going to do this. You're going to say k, close open k, close equals to 0. Then I'm going to look for factors of 54. That can give me 3. When I look at factors of 54 that can give me 3, it can be what? 9 times 6. Because here, 9 times 6 is 54. So I'm going to have what? 9 and 6. Because 9 and 6 can give me 3. And when multiplied by each other, they can give me 54. But because the middle term is negative, then the bigger number will take negative, and this one positive. And you multiply them, they will give you negative 54, right? I'll teach you how to factorize on one of the next videos that I'm going to post. So now I have gotten my k. Remember zero factor theorem? This being equated to 0, product of two numbers or two expressions being equated to 0, either this is 0 or this is 0, right? So you're going to say k minus 9 equals to 0, or k plus 6 equals to 0. So now my k is equals to 9, or my k is equals to negative 6. Guys, the moment you get your k, just know that you were not solving for k, you were solving for tan. Remember that, right? Because you let k to be this. So you're going to have to substitute this back to k. So where I see k, I substitute back my 3 to the exponent tan x. Okay? So I'm going to write 3 to the exponent tan x is equals to 9. Or 3 to the exponent tan x is equals to negative 6. Right? But we all know that an expression which is a power, right, which is positive, being equated to a negative number, can never yield, meaning it is non-applicable, because there's no way there can be a value of tan x that will yield an answer that is negative, right, according to mathematical logical blah 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 blah, right? So you just say not applicable. Okay, so now we are here. Now I will remember, guys, the moment you have a base and an exponent and something that is not a prime number, you have to convert it to a prime base, and the prime base will be 3. So you're going to have 3 tan x being equated to 3 squared. Now when we have bases being the same and the whole powers being equated, then it means when the bases are the same, then it means you can equate the exponents, because there's no way tan x can be 3. Imagine if you have 3 cubed being equals to 3 squared. You know it won't apply. So therefore, it means tan x is automatically 2, right? For these two expressions to be equal, tan x has to be 2. So it means, therefore, my tan x is 2, right? So then from here is general solution. It's general solution, guys. It's general solution. So now let me take this paper, let me put it aside, and now let me treat general solution. So I'm gonna take it, I'm gonna say, there we go. So now we have general solution of tan x equal to t. Okay, so how do we do this one? Now, this is a general solution question. Basically, what we did previously was not necessarily finding the general solution. We were solving an exponential equation. So this is what happens with the general solution questions. You have to first simplify, apply other concepts until you have something of this kind. Then from here onwards, that's where now we are doing general solution. So general solution, guys, is easy. If you really think about it, it's easy. The only thing that is challenging is when you simplify whatever expression or question that they gave you so that you can find something like this, so that then you can, find the general solution. So the challenging part is simplifying, but general solution is easy. But let's just do it for the fun of it. Otherwise, let's see. Now we have tan x equals to 2. The first step in general solution is doing what? Come on, guys. We have to find the inverse function, right? Tan. So we're going to say what? We're making x the subject of the formula. We're saying x equals to what? Arctan, right, of 2. And for South Africans, for South Africans, especially CAPS curriculum, you will say x is equals to what? Tan the inverse of 2. Okay, so this is the inverse function. You call it arctan 2, but you can just call it the inverse function of 2. No problem. Either way, whether you write this or you write this, you get a mark, right? So yeah, you're gonna do this so that you can make x the subject of the formula. We call this x the reference angle. So you're gonna say reference angle, x is equals to. Then you press your calculator. Okay, you press your calculator. You're gonna find an acute angle. So I'm not gonna press my calculator. I'm just gonna write tan negative, right? So it's gonna be what? Tan the inverse -1 of this, so that I can give you the rule, right? So what you're gonna do, the step, you see this step, guys, this is how I think when I'm looking at it, especially when I was in high school. I was looking at it this way. I said the step that came before my inverse function, that's the step I check. I will check what? I will check my solution here on the side, if it's negative or positive. Okay, so I'm gonna check this. Is my 2 positive or negative? It's positive. Therefore, I will check in this Cartesian plane where my tan is positive. If this is positive, I will check where my tan is positive and I will take. If this was negative, I will check where my tan is negative in this Cartesian plane. Okay, so now that my 2 is positive, I will check where tan is positive here. So I will say tan is positive where we see all trig ratios being positive, and tan is positive here. Here, this is the first quadrant, and here is the third quadrant. Okay, here is the second, and here is the fourth. Okay, so in the first and the third quadrant, that's where your tan is positive, which means my general solution is going to be found in the first quadrant and the third quadrant. Okay, so I'm gonna say in my first quadrant, I will take my reference angle as it is. I will say x equals to the reference angle as it is. Let's say you found 30 degrees. You can press on your calculator and find it. You just write it the way it is. You write it the way it is. You be like tan the inverse of 2 plus, and remember, guys, the period for tan. We're going to talk about this when I treat trig ratios, trig graphs. Okay, the period for tan graph is 180 degrees. Therefore, my k, which are my integers, my k will be multiplied by 360 degrees. So you're gonna say x equals to the reference angle plus k, 180, and I just spoke about it. Hey, you know me. Yeah, I'm a human being. So yeah, it's k 180. Here you write the period of tan. If it was sine or cos, I was gonna write 360 because the period for sine and cos are 360. Okay, so then you say, what is this k thing? This k thing is the element of integers. We're gonna talk about it when we treat trig graphs. So now you are done with the first quadrant. Now I have to treat this third quadrant. When it comes to the second, third, and fourth, always play far from 90 and 270, but play very close to 180 and 360. So these two quadrants can only be represented by what? By 180 minus, right? Remember the mnemonic for those who have already taught. For those I haven't taught before in my life, I'm going to have to, record a video for that. So it's going to be 180 minus the mnemonic. And in this quadrant, we have what? Which means it's 180 plus. So for this quadrant, it's going to be 180 plus the reference angle. Okay? So I'm going to say in my third quadrant, I have what? My x is equals to the reference angle being added onto 180, right? So it's going to be what? 180 degrees plus the reference angle, which is tan the inverse of 1, the inverse function of 2, right? Remember, you are going to press this on your calculator and find the value. Then you're going to take 180 and add that value and find the final answer. Okay? Then you say plus k 180 degrees, where k is the element of integer. Guys, these things are easy, interesting. So I hope you understood, and I will see you on the next video. Dropping the mark.